So why do we need responsive web designs? With more devices come varying screen resolution, definitions, and orientation. New devices with new screen sizes are being developed every day, and each of these devices may be able to handle variations in size, functionalities, and even color. You need a design that can accommodate for the varying screen sizes. There are some in portrait, some in landscape. They have different shapes. iPad, Techno, different devices with different screen resolution and sizes. So you need a design that can accommodate that switch easily from desktop view to mobile phone or to the iPad. Responsive web design is important. So the first technical approach I'm taking is that when designing, keep in mind that you always have to use the best practices. What I mean, the first thing to keep in mind is that when designing a website, you should always understand that your design should go from simple to complex. So we use media queries when you want to design. We use media queries to design. It is media queries is the property you use to tell the computer that this particular design is for desktop view or this particular design is for the mobile view. So the best practice is you should always design for mobile first before designing for desktop. Some people design for desktop first before designing for the mobile view, but that is not the ideal way. So when creating responsive web designs or responsive web pages, the first thing is that you should always design for, for mobile first before going to desktop. That will mean you are following the principle of going from simple to complex. But responsible design is not only about adjustable screen resolutions and automatically resizable images. It is more about the way you think about design, the ideas you put in when designing, and another technique I will tell you is about making sure everything you design is flexible. Your layout is flexible and everything is flexible. It is important that you design your web pages in sections, in columns, or in parts. That way, when you want to move things around, you are not moving just the text or little fragments around. You are moving entire sections around. So this solution gives us far more options. It is perfect for devices to switch from or to switch orientation from portrait to landscape in an instant, or when users switch from large computer screens to iPad. The thing about using media queries is that we must consider the hundreds of different screen sizes. Yes, it is possible to group them into major categories and design and make designs for each categories. You can see for screen sizes of from PC screen sizes from this text or from this size to this particular size. Then use media queries to state that this design is for this screen size. Then from this particular screen size to this particular screen size, you say this design is for this design. Yes, we can do that, but considering the ordering of screen sizes, it might be overwhelming. And it will not just make everything as flexible as necessary. So it is important that when designing, rather than just using media code, you keep in mind that everything must be flexible and designed in columns. A few years ago, when flexible layouts were almost a luxury for websites, the only things that were flexible in the design were the layout columns and the text. Images could easily break layouts, so you should keep in mind that one important part of designing is that you should make design in such a way that it will accommodate for images regardless of the size or resolution. Flexible designs weren't really that flexible in the past and they could give or take 100 pixels, but they often could not adjust from a large computer screen to a smaller overall size. Now we can make things more flexible. Images can be automatically adjusted and we have workarounds so that the layouts never break. While it's not a complete fix to the solution, it gives us far more options when using flexible layouts. So one solution to that is using the height when you're making a image to the website, you use the height property and set the value to auto and give it a width of 100%. That this command or this code just makes sure that your image, regardless of the if it's not a complicated website, if it's a simple website, that regardless of the platform you're doing the website on, it just shrinks the size of image a little, and it allows you to view. You put the width at 100%. It allows you to view the entire image regardless of the screen size. But another way of going about images is that when if you are thinking about performance, I mean low time, a huge image of size 50 MB would not load easily on a mobile phone or let's say Nokia C1, those old phones, because of the size of the image. It's very big, and this will cause your website to drag and be slow. So that is what we have the picture property for. When designing, most people don't use the picture; they use the image tag when in HTML when designing this thing because that is just what everybody does. But the picture tag allows us, so for a website, if you have a particular image you want to load, you want to link to that, you want to load on that website, you can have the same image but with two different sizes or resolution. So if you have an image of 50 MB, that same image you will have another type that is 5 MB. So when then you now use the source set when using the picture tag, you use the source set. The source set allows you to you tell the computer or you tell your code that when you are viewing this website, when you this if you are viewing this website from a desktop view or a laptop, you load this 50 MB sized image. Or if you are viewing that same website on a smaller phone, you load the same image but the 5 MB one, not the 50 MB. So inside that picture tag, it allows you more control, and you can use different images, same image but different sizes. You loaded differently on different platforms. And so finally, if you have videos, one technique you can use in handling videos on your website is using the object fit property when using the image tag. This allows you to size the videos or pictures, and you can state the width and the height specifically to allow it to accommodate on your website. So thank you. That was and if you have any questions, let me know. Hello?
Yeah, we can hear you. Does anybody have question for him? Does anyone have question for him? In 5 minutes, can you quickly do a recap of everything you've taught us this morning?
So I was talking about can you hear me?
Yes.
So the topic I took was time saving CSS techniques to create responsive designs. And I stated that HTML is the language that allows us to structure our websites, um, while CSS is used to style it. So now we need techniques that allows us save time when creating or when designing our websites. And when designing websites nowadays, you always have to make sure that your website is responsive. And when we talk about responsiveness, it's relatively new, as in as people didn't really used to think about design that way. But in this age, you have to make sure that when you're designing a website, you design your website in such a way, the ideas and the things you put in design, it has to be in such a way that your website looks good on every platform. And I mean the website can be built because unlike in the past, now if you design a website, it is more likely that most of the people that will access your website will do it from a mobile device. So you make designs for the mobile view and for the desktop view for the iPad. And media queries it's the command, it is what you use in designing different or in making different designs for different platforms. But the thing about using media queries for responsive clients, you need to use them. But the thing about using them is that there are so many screen sizes and resolutions and different platforms on which your devices or your website can be viewed on. So you have to keep in mind that just just making design in such a way that for big screen sizes, this is um, what this website will look like. For smaller screen sizes, this is what this website. It's not always 100% efficient. You have to make your design so you have to make your design in such a way that um, it can look good on every platform regardless. So responsive design it is the ideas you put in design. The first thing I spoke about when designing is that you make sure that you design for the mobile first when design. That means you are going from simple to complex. Um, the second thing I spoke about is that you need to make sure that everything you design is flexible. You make your designs, your website, you make them in columns or in sections so that when things are moving around, you are not just making the image doesn't just shift to one side or this particular text or column just shifts to one side. You have to put everything in sections so that everything can easily move around. So when things are moving, it is the sections that are moving. So rather than having 100 things moving around on your web page, you can make those 100 things and categorize them into 10 smaller sections. So when things are moving around, it is those 10 things that are moving, 10 things that are moving around, and that is better. It makes your website look better when switching from maybe portrait to landscape or from iPad to the iPhone. Then when dealing with images, one if you are viewing the website from a simple web page, one easy way to go about it is setting the image tag and using the property height auto. So when you use the height auto, it allows you view the entire image. It doesn't cut off a particular part of the image. It allows you view the entire image regardless of the platform you are accessing the website from. And you also use the width property and state the value as 100%. That allows you to view the image. Then another way of handling image is that, for instance, another technique is that, for instance, if you have a large image you want to load on your website, and there's no problem using that image, but for smaller devices, the image might, because of the size of the image, it will cause your website to be slower, to load slower on the smaller device. So we can use the picture tag. So instead of using the image tag on the website, we use the picture tag. The picture tag allows you more control, as you can state the source set and source media. What this allows you to do is that if you have a particular image that is, let's say, 50 MB, you have that same image of another size 5 MB. That means a smaller size version of that same image. Then you tell your website that, if this website is built on a large screen size of, from this we state the market from this size to this size. Let's say from desktop upward, screen size is 1080 or something like that. They about upward. You load this particular image of 50 MB. Then when you now state that in that same picture tag, if you are viewing the website from a smaller device, let's assume an iPhone 5, then you load this particular image, the same image but the one of 5 MB. So this means that your website loads fast on the desktop and even on the smaller device. The website it loads faster there too. Then the last technique I spoke about is that when you have videos on your website, you can use the object width property and set the value to cover. Then you state the maximum width and the maximum height. So these are easy and time-saving techniques you can use when designing your website and the approach. Thank you. That was what that presentation was about.
All right, thank you for your beautiful presentation. Now, does anyone have a question for him? Does anybody have a question for him? Okay, let's quickly do an exercise. Samuel,
Yeah.
do you have a question?
Let me see. Okay, yes, I have a question.
Yeah, you can check to the participant list and mention anyone's name.
Um, Adeleke Adekunle. I can't. How do why do we need to design for mobile first before designing for desktop?
Hello, good morning. Can you
Good
hear
morning.
me?
Yeah, I can hear
Okay,
you. Good morning.
okay. So, first of all, I think it depends on choice. Am I correct? One could choose to design for the desktop before designing for the mobile as well. But so designing the mobile first means you you are trying to be sure that you have a good how would I put it? A good uh, output of the device. That means you're structuring the design for the mobile first, and then you can grow, then redesign you can redesign further for a desktop view. That would be easier since it's sometimes more complex when you have everything in the desktop view already and you're trying to because the more the screen resizes comes smaller, the object tends to scatter around and all. I don't know if I'm making sense.
Yes, you're making sense. You have a point. Yeah, not entirely correct, but to an extent.
Yeah, so
There, there is no
Next person, next person, next person. You don't need to answer the
okay,
question. Let's next person.
okay. Let me see.
Good morning, sir.
Okay.
I think someone is talking.
Yeah, yeah. Do you have a question?
I just wanted to confirm that I'm still presenting today. If I'm still presenting today,
Oh, Patrick, you're welcome. Okay. Samuel, you can answer the question now. So let Patrick present.
Oh, okay. Yes. I was going to reply, but yes, I said it was correct to an extent. It is easier. It makes it more. It is less complicated when you have to design for mobile first, then before you now go to desktop, because that means you are going from simple to complex. But if you design for desktop first, it is more complicated and it will take you more time before you start removing and shifting those things around to now make the design suitable for to mobile. So ideally, it is a general idea that the best way to go about it is that you always, when designing, you always design for mobile first rather than design for desktop first. So that's the answer. Thank you.
Victor, today is not your presentation day. Okay, Patrick, you can come up. So I can stop sharing your screen. Thank you.
Okay. Can everyone see my screen?
Yeah, you can.
Okay. Good morning, everyone. Today we're talking about IP address and subnetting, the basics of it. Okay. So, first of all, I'd like to explain things little by little. What IP means, what IP address means, and what subnetting and subnet marks means. So
Please,
now,
before you continue, is it possible for you to share your video also?
Okay.
If it's not possible, you can. I know you're using it. Oh,
Are you seeing me now?
yeah, we can see you.
Okay, but I have to flip the screen so it's
I know, no
big.
problem.
Okay. So now, IP stands for Internet Protocol, which is a suite of communication protocol used to interconnect network devices like router, switches, and etc. on the internet. Basically, IP is a protocol used to protocol which help to connect devices, maybe computer, phones, every um, device an IP attached to it. So now going to IP address. IP address is a logical numerical address assigned to every single computer, printer, gigabit, Ethernet switch, router, or any device in a TCP IP-based network, with each of them possessing a unique IP address. So what this is saying basically that every device has an IP address, and this IP address are unique, and it helps devices to communicate with other devices on the internet. So now, IP addresses can be of two types. It can be IPv4, which is a bit um, a bit long. Then we have IPv6, which is 128 bits long. And also, there are also unique addresses. An IP address consists of 4 bits of data, which a byte consists of 8 bits of just ones and zero. Therefore, we have a total of 32 bits for each IP address. Then this is an example of an IP address in binary. So now to simplify things, the decimal representation is usually used to make IP address like this. So this 172.16.254.1 we are saying was what is represented above by in binary 101001. Then IP addresses have classes and they have range and they have default subnet marks. Now, this is a table showing different classes, the ranges, and the default subnet marks. So now for class A, we have from 1 to 126 and default subnet marks 255. Then for address class B, we have 128 to 191. And the default subnet marks is 255 to 255. Then for address class C, we have from 192, from 192 to 190 to 223. Then the subnet max is 255.255. Then we also have for D and E, which for D is from 224 down to 239, and which is subnet max is reserved for mostly multicasting. And also for class E, we have the range is 240 to 254, and the subnet max is also for experimental purpose. Then we should also know that address class 127 from 127 to 127 can be used and loop back testing. Okay, now going to subnetting and subnet max. Subnetting is a process to divide the larger network into smaller subnetworks. That is subnet. We always reserve an IP address to identify the subnet and another one to identify the broadcast address within the subnet. A subnet max is a 32 or a 128 bit number that segments an additional IP address in a TCP/IP network. It is used by the TCP/IP protocol to determine whether a host is on the local subnet or on a remote network. Subnet mask divides the IP address into a network address and host address, as to identify which part of IP address is reserved for the network and which part is available for host use. Basically, let me summarize that. Subnet is a way of dividing your IP address into different IPs, such that you tweak it a little so as to have different different addresses from just one particular address. Then reasons why you should subnet. Number one, we have improved network security. So now, having your entire network in one subnet could seem easier, but what if a device in that network gets compromised? Then your entire network and all of the device within it immediately become visible because you're using just one. But if you break the network into different subnets, you are able to control your address. Then number two, we have better network performance and speed. If you're not using subnets in your network, a single broadcast packet will send out information that will reach every device connected to that network due to each device points into the network. Since they all have the same IP address, so if you send something, they are going to all receive it at the same time. But if you subnet it, different address will receive a different information based on which address you sent it to. So the administration is a breeze. So as the net admin, subnetting can help make your life easier. You are able to create networks with more realistic host limits as opposed to the limits imposed by IP address classes. Then easier to control growth. That's number four, easier to control. Number four reason why you should subnet your IP address or network. Easier to control growth of network. When you subnet your network, you have the power to control how much your network grows. Like when you need to expand. When thinking about how large you want your network to be, you can use what is referred to as the host formula, which says that take number of zeros in the marks of your subnets when converted to binary, and you take 2 of the power of that number minus 2, you will see the number of possible hosts when using the subnet max. Then finally, less network congestion. Subnetting adds order and increased performance by splitting up traffic in larger network. When you subnet your network, you ensure that traffic. When you subnet your network, you ensure that traffic is reduced for a particular device within that subnet, stays within the subnets. This will minimize congestion in other parts of the network by placing subnets to minimize congestion. Companies can reduce the network load and route traffic more efficiently. Okay, how do IP address and subnet masks work? Basically, in TCP/IP configuration, we cannot determine whether a part of the IP address is used as network or host address unless we get information from a subnet mask table. If the subnet mask example is 255.255.255, which corresponds to /20/24, and since 255 is binary notation, equals 1 in 1118 times. So the subnet max is 1113 times .000. Towards the end of this, I'll quickly explain what I'm about to get the subnet max. Then lining up the IP address and the subnet max together, the network and host portion of the address can be separated. Okay, let me quickly go into how this with an example. Okay, now the example says, what is the subnet address, first usable address, and broadcast address for IP address of 192.168.5.12/26. Okay, now from this address now, I can deduce 2 things. The address by my left-hand side, that is 192.168.5.12 is the address, and the /26 is the default net max. So now, to Okay, this is a solution. But first, I would like to guess the address class for this address. So now going back upward from my charts, let's check what class is this address. 192.168.5.12/26. Comment, sorry. Okay, from this table now, we can actually get the address class. So now you notice that it begins with 192. So now it's drained it from 192, like I said. So now we can see that it is a class. The address class is C, the class C address. I just wanted to show us how to identify the class from the table. 192. Okay, now the subnet max is 26. So now there are different ways to calculate the subnets, the hosts, but this is an easier way to do it and a faster way. So now from this table now, I can calculate my host and my subnets. So now all I do is just from what I got, I have /26 subnet max. So I'll just trace it up. The third column, that's /26, I trace it up. That will be the host, that is 64, and the subnet will be 4. There are different ways to go about it, but then this is the simplest way to do this. So now from that, I have my host as 64 and my subnet as 4. So now from the table tracing 26 upward, host is 64, subnet will be 4 in number. So now the subnet will be 4 in number, starting from 0 and adding 64 to the last number. So now our subnet address will be starting from 0, 192.168.0. Then the next one, you add 64 to it, since the host is 64, 192.168.5.64. And the third one will be 192.168.5.128. And the last one will be 192.168.5.192, making it 4, like we said. The subnet number of subnets. So now the first usable address will be 192.168.5.1. That is after the first one after the 0. That's the first one. And the broadcast will be 192.168.5.63. That is the last host before next subnet. Thank you. Don't even anybody ask any question to ask, or if I need to explain anything.
Okay, I have a question, but funny though. How long? Oh, wait. Would you have to master all these numbers before you use internet protocol or whatever you say? IP address.
Okay. You could if you want to, but then, like I said, this is a simpler method of doing it. Okay, but you have to also know how to. You are seamless when working with IP address. There's an easier way of converting to from decimal to bits or to decimal or to binary. All you have to do is just okay. I can't explain that without writing down. So but then there's a simpler way of
so you, you have to write numbers down. This I don't understand. It is where any question.
Try your calculator to convert to instead of wasting time too. And they are converters too.
I would have to be converting all these numbers. Okay, it's a nice thing though. Who else have question for him? Just talking about numbers this morning. Okay. Who else have question for him? Okay, if there's no question, Patrick, do you have question for anybody? You can just check to the participant list. They mention anyone's name.
Okay, I have a question. If I'm to change this from this same IP address to slash 24 instead of 26. Can anybody tell me what the address class will be? Okay. If I'm to change this IP address from slash 26 to 24, can anyone tell me what the address class is going to be? That's the question. Okay, let me check and pick someone. Okay, I can't access this. Okay. Okay, Emmanuel. Mr. Emmanuel. Can anyone hear me? Hello?
We can hear you. Which of the Emmanuel?
Okay, Ogwo, sorry.
Do you have a slide that shows the classes and the values?
Yes, I do. I'm going to go down there now. Okay. This is the range, and this is the default subnet max. So I changed it from C/22/24. And the address is 192.168.4.0/24. 168.4.0/24. The /24 is subnet max. Okay, let me make it easier. The /24, you can convert it to /24 is actually in decimal. So now 24
just
is
to confirm something, is the IP you showed is in class C?
No. Okay, yeah, the one I showed before, the 4/26 is in class C, yes. The class C address.
But when you change it to 24, then the class changes.
Yes, it will.
Explain what you mean by 24 is a decimal.
Okay, by that I mean that if you check the subnet max table now, there is no 24 there because this is in binary. So now, I'm sorry, this is in decimal. So this is decimal name. So now 24 means 8 times 3, if I'm not mistaken. That's 24. So now 8 stands for like 1, 1, 1, 1, 1, 1, 8 times. So now 1, 1, 1, 8 times to give you 255. That's the first 55 you're playing. I'm playing with 26 now. From there, you can answer for 24. So now for 26, you're going to have 1, 1, 1. You're going to have 1, 1, 1, 1. That's 255. That is 2 raised to the power of 8.
Chill, you explained for 24 or 26.
I'm trying to explain for 26, so you can use that to answer for 24. Okay. Because you will notice they have the same address, 192. We started from 192, so you cannot pick that you can't pick that using the range. You're going to pick that using the subnet max, since that was different. So now, as I was saying, so the next, I said 26, right? So now 8 times 3 will give me 24. That's remaining 2. So now the remaining 2 is at the end of the subnet max. I don't know if that makes sense. So now the 255 is actually standing for a binary of like 1, 1, 1, 1, 1, 1, 1, 8 times for each. Then the second one too, 1, 1, 1, 1, 1, like that. That's why I got 24. So now, if you notice, there is still one. There's still one left, 0. It means that we can have more, which is the remaining one we have for the 26. Like it's not a complete one.
Okay, before you finish what you're saying, let me just so I don't end up wasting your time and not giving you the correct answer. To do this, I would need the formula and I would need to do some calculations.
Okay.
So it's not exactly a question that you throw from what you've done, and but I kind of understand a bit of what you're saying now, because if you're 20, if 24, it's I have to do some conversions from binary. Then I have to do calculations using the formula of finding this IP. Something I'm going to answer on
Let me ask
spot.
a simpler one. Okay, let me ask a simpler one. Okay, it's that same question. What's the host and the subnet for that same address /24?
What is the host and the subnet?
Yes. For
Sorry, can you
/24 subnet max.
The subnet would be 1 if I'm using this table here. If you are saying
yes,
then the host will be 256.
Yes, with this table, you don't have to calculate anything. You just get it from there. You're correct. You're correct. Thank you.
Where do you get the formula and logic for all this?
Okay,
because now it's let me give you an example. The question you ask first would be something like asking me, what's the host and subnet for /30 when I don't have this table anywhere or the formula for this anywhere. So that's why I'm asking where you got the formulas and
okay, the formula to actually to calculate number of subnets, it's 2 raised to the power of subnet bits rather. Then to calculate the number of hosts is 2 raised to the power of subnet hosts. So now, for instance, now /26 that we did earlier.
Yeah.
Okay. The number of subnets. Okay, we still have to go back to the conversion, like I said. So now, since it's /26, I can say 8 times 3, that's 24. I'm using 8 because 8 is the range. That is, it will not be more than 256. That's the highest we can go on a binary. So now,
okay.
So now I'm using 8 because I can easily divide the /26 or /anything easily. So now 8 times 3 will give me 24. So now 24 remainder 2. So now I'm not very concerned with the 24. I'm concerned with the 2. The 2 left now is the subnet bits. So now 2, like I said, the formula is to get the subnet is 2 raised to the power of the subnet bits. So now that 2 left, 2 raised to the power 2 will give me 4. That's how you get the subnet. That's 4. You check it from my table here. So I to give you a subnet of 4. So now from that to now, was that clear?
Yeah.
Okay, from that to now, we know that every binary would end with a subnet binary we end in 8. It must be 8, like I explained. It must be 8. Each of the addresses will be 8 dots, like 8 digits, like 1, 2, 3, 4, 5, 6, 7, 8. Each adding up must not be more than 256. So now I have 2 left, so now I'll be left with 6. 8 times 3 was 24. 24 plus 2 give me /26. Sorry, I know it's sounding so okay.
See what something you can do is provide the resources for this presentation. Okay. So anytime I have to calculate something, or anytime I have to figure out what subnet, mask, or anything is, I have somewhere I can go to see the formula.
Okay. That's why I actually use the table. You don't have to calculate anything.
Oh, okay.
I was just trying to explain why I got the table.
All right. Thank you.
Yeah. Thank you, sir.
All right. Thank you. That was a beautiful one. Okay. So right now I will bring the session to an end, and we could join the stand-ups now. Thank you everyone for attending this morning. Katie, have a good day.